Tesla facing a class action lawsuit over its EV driving ranges.
Tesla may have used an algorithm to improve or show rosier range.
EV manufacturers accused of cheating range estimates and how this affects you. Gas engines used to be really popular, and their pollution has been tested by the U.S. Environmental Protection Agency, or EPA, since the 1970s. But now things are changing fast. Electric cars in the U.S. are selling a lot more, increasing by 55% in 2022 alone. This is a big shift that's changing how things work on the road. EVs are like futuristic messengers that move quietly and don't emit pollution. Sounds great, right? But there's more to the story. Car makers need to prove how far these electric cars can go on a single charge. The government is also involved in these tests, but there's a worry called range anxiety, where people are scared their electric car's battery might die while they're driving, leaving them stuck on the road. This worry is making some people unsure about switching to electric cars, and to manipulate the buyers, the EV makers have also taken a questionable route, lying about range estimation. In this video, we're going to delve deeper into this matter and see what's really going on in the EV market. Here's the thing, the EPA, that mighty guardian of eco-consciousness, gives the thumbs up to US road driving conditions, stamping them with a seal of approval that outshines the global competition. But critics can't help but point out a 12% underperformance hiccup in the system. This little hiccup has blown up into a full-scale fireworks display of brand differences. Tesla and Porsche talk big on paper about their ranges, but in reality, their cars' actual ranges can't match up very well. According to Reuters, not only has Tesla been deliberately programming its cars to exaggerate their range estimates, it has set up an entire division to deny and obfuscate owners' accusations that such exaggerations exist. Reuters cites an insider who says Tesla deliberately rigged its cars' onboard range estimating software to show, quote, rosy projections for the distance they could travel on a full battery. To put it differently, the car was designed to lie. Porsche or Ford didn't make any comments on this. Mercedes-Benz told Reuters, "We follow a certification strategy that reflects the real-world driving behavior of our customers in the best possible way." So, let's check out the EV range determination and the EPA's process. CNBC explored the EPA's lab in Michigan, revealing how they assess EV ranges. The lab examines not only cars like the Chevy Bolt, but also trucks, lawnmowers, and snowblowers for range accuracy. Manufacturers take the spotlight, testing and sharing results with the EPA. Yet the EPA can independently investigate any vehicle. It's like a reality check during major updates, where harmony is usual. But clashes lead to investigations and retests. The EPA's word is final, putting a decisive end to discrepancies. In the audits of EV manufacturers' range testing, the EPA has encountered a wide range of estimates, both conservative and optimistic, from various automakers. That is what we expect when we have new manufacturers and new technologies entering the market, and why EPA prioritizes auditing them, the agency said. And then there's the grand reveal. Around 300 vehicles take the stage each year, a dazzling 15% to 20% of the US fleet. It's a lineup that spans the spectrum, from fresh-faced rookies to seasoned pros, showcasing their prowess throughout the seasons of their lives. But there's more to this show than meets the eye. The data isn't just for showbiz. The Department of Transportation swoops in, snatching up the numbers for fuel economy standards, while the IRS plays its part, slapping the gas guzzler tax on the more voracious vehicles. Now, let's peel back the curtain on the testing process itself. Prepare to be amazed, because we're diving deep into the mechanics of EV testing. Picture this, an EV battery basking in the sunlight, soaking up the charge overnight. With the dawn of a new day, the real show begins. The EV struts its stuff on rollers that mimic real-world conditions. But it's not all smooth sailing. Testers can crank up the resistance to mimic a bite of wind. A real-life driver takes the wheel while a clever machine measures the battery's discharge rate, all based on speed and distance. In a steady state, the EV maintains speed until the battery depletes. After recharging, the race is on to revive the EV, testing power and endurance. The city driving test combines with the highway for faster battery depletion. Testing time goes from marathon to sprint. Don't forget the enchanting reduction factor, a touch of magic that takes lab results and sprinkles them with a dash of real-world seasoning. But wait, there's a bonus round, a 5-cycle option that's like a blockbuster movie for gasoline cars. It's got city jaunts, highway adventures, temperatures, weather twists, and even a dose of aggressive speed. It's the showstopper of EV testing, with speeds pushing 80 miles an hour and drama in every curve. The EPA isn't just relying on the dynamometer's mesmerizing dance. They're pulling out all the stops, comparing these lab results to real-world action. And it's not just about how the car performs. They're digging into battery charging patterns and even tackling the intricate effect of temperature. Think heated seats and the chills of winter. It's a research journey that's unfolding like an epic quest. EVs are hailed as a cleaner and quieter future for transportation, but their unique challenges perplex the EPA during testing. Unlike conventional engines, EVs constantly evolve, making standardized testing difficult. It's like fitting a square peg into a round hole. Measuring power, efficiency, and range is complex. EVs rapidly advance, with older models swiftly succeeded by more advanced counterparts. The EPA must match the automotive landscape's innovation. Yet here's the twist. Every EV manufacturer marches to its own tune, boasting unique methods to quantify their vehicle's power dynamics. The result? A cacophony of discordant data that hinders the EPA's quest for lab results mirroring real-world conditions. Imagine trying to compare apples to oranges, and that's what the EPA faces in its pursuit of consistency. Don't believe everything you read on the label. That's the adage of the world of EVs. The mid-90s saw the EPA donning a new armor of rigorous testing cycles to align fuel economy estimates with reality, but the truth remains elusive. External tests continue to reveal gaps between EV ranges and EPA ratings, like a curtain being drawn to reveal a backstage of uncertainties. Let's talk about real-world examples. A 2018 Model 3, in the grip of cold weather, mustered a mere 65% of its claimed range, according to Car and Driver. AAA, on the other hand, revealed that electric trucks under load suffer a 25% drop in range compared to the EPA's promises. Edmunds, the discerning critic, pointed out stark differences between their EV tests and EPA numbers, while a daring Porsche Taycan shattered expectation by going beyond its EPA range in a single charge. Then enters the Society of Automotive Engineers, bearing a paper of criticism, targeting the very methods of EV range testing. This paper, like a gust of wind, sweeps up concerns. One stands out: the discrepancy between how EVs and their gasoline counterparts are judged. EVs are bestowed a single total range number, while gasoline champions are weighed in both city and highway contexts. The playing field is skewed towards city driving, favoring EVs in urban areas due to regenerative braking. However, this advantage diminishes on highways, causing range anxiety for EVs. Regenerative braking evens the highway test, but the actual results differ. Car and Driver's 75-mile-per-hour test is eye-opening, with conventional cars exceeding EPA promises by 4%, and EVs falling short by 12.5%. Driving style impacts the range significantly. The range depends on terrain, temperature, and speed. A single number doesn't capture reality. Gregory Pannone, the former head of fuel economy at Chrysler, described Tesla as the most assertive electric vehicle manufacturer in terms of range estimations. "I'm not suggesting they're cheating," Pannone said of Tesla. "What they're doing, at least minimally, is leveraging the current procedures more than other manufacturers." Edmund.com's testing director, Jonathan Elfalin, reached conclusions similar to Pannone's after examining Tesla and other automakers' vehicles. In February of 2021, Edmunds tested 5 Tesla models. None met the advertised range. Most non-Tesla models did. Tesla claimed a meter safety buffer, but retesting in March 2021 showed only 2 of 6 Teslas matched the range. Elfalin said they've gotten really good at exploiting the rulebook and maximizing certain points to work in their favor involving EPA tests, Elfalin told Reuters. The practice can misrepresent what their customers will experience with their vehicles. The EPA has different methods for testing gas cars and EVs. Gas cars are tested with 5 different driving cycles, while electric cars are tested for maximum distance. To fix this, they should display standard ranges for both city and highway driving, using consistent tests. As labs improve the tests, the range estimates will get better. Just like gas cars, electric cars' labels will change. In 2025, a new cold weather test will be added, which might reduce the current EV range, showing how these range settings are changing as the EV industry matures. The EV revolution is reshaping the auto industry. Amid the excitement, remember Dieselgate's lessons. Customer bumper protection is vital as EVs move in to dominate roads. So the question remains, do you think stricter regulations are needed to prevent such discrepancies? Have you experienced any discrepancies in your EV's range? Share your thoughts in the comments below. If you found this video informative, don't forget to give it a thumbs up and subscribe to our channel for more updates on electric vehicles, industry news, and tech insights. Thanks for watching.